Okay, so we were at number 13. So in number 13, we have the square root of 10 times the square root of 15. Now, we could multiply these together, or let's just look at prime factorization right away. This is 2 times 5, and this is 3 times 5. So, even as we're multiplying it together, I get 2 times 5 times 3 times 5. We could just write 10 that way, and write 15 this way. It's true, you could just write this as the square root of 150, but at this point, what you're going to have to do is take the prime factorization anyway. So here, we've just worked with it already. So we could write this as the square root of 2 times 3 times 5 squared. From here, we can see then that there are 2 5s. So 2 5s can come out as 1, and we're left with the square root of 2 times 3. They have no pairings. So this is just equal to 5 times the square root of 6. And we did very little multiplication there, higher multiplication than 10 and 15. In number 14, we could take the cube root of x to the 12th. So now our index tells us that we're looking for a group of 3. So let's try and rewrite 12 in terms of groupings of 3. Well, I know this. When multiplying with like bases, I could add the exponents. So for example, x cubed times x to the times x cubed is really x to the 6th. If I add another one, that's x to the 9th, and one more would be x to the 12th. So I could break these up as the cube root of x cubed. This one comes here, times the cube root of x cubed times the cube root of x cubed times the cube root of x cubed. And now each of these can be simplified. This one becomes x. This one becomes x. The multiplication still stays. This one becomes x. The multiplication stays. And this one becomes x. The multiplication stays. So in the end, we have 1, 2, 3, 4. So we have x to the 4th power. So this is the long way to go about doing what we're doing, but that is the explanation for what I'm about to do will work. What we wonder then is, since we're looking for a group of 3, we wonder how many groups of 3 are in 12, which is this. And this is our root. And we find out that that is 4. And that is the resulting exponent. Let's get some more practice. Number 15. We have the square root of x to the 10th. Now again, we could write this all out looking for groups of 2, remember, because this is the square root. Or we can just ask, how many groups of 2 are there in 10? Well, there's 5. So that must be the power. In 16, we have the square root of x to the 15th. So again, we'll ask ourselves, how many groups of 2 are there in 15? Well, 2 goes into 15 7 times. 7 times 2 is 14. And there's a remainder of 1. So that means we could write this as x to the 14th times, because 7 and 2 are 14, times x to the 1st, then the square root of x to the 14th times the square root of x. Here's our remainder of 1. But we know this, that 2 goes into 14 7 times. So this will simplify to x to the 7th power. And the square root of x must come along. Let's do 17. The cube root of x to the 20th. Now, our index here is 3. Okay, so we're looking for groups of 3. So we're asking ourselves, how many groups of 3 are there in 20? So 3 goes into 20, well, 6 times 3 is 18, and we have a remainder of 2. So from here, we could just write this as, well, how many groups of 3 did I have come out? I had 6 groups. And how many do I have left over? I have the remainder left over, which is 2. And I have to remember to put the cube root in there. So be careful about how you're writing things. This index, this n, our 3, must be written very small. Okay, square root of y to the 17th. Again, the process is the same. The 2 is missing from there, but we understand that. So we ask how many times does 2 go into 17? Two goes into 17, well, 8 and 8 are 16, so 8 complete times with a remainder of 1. So from here, we can write then that this will be the square root. I had 8 complete y's come out, and I have a single y left over from this remainder. Now in 19, we're taking a 4th root of m to the 27th. So the process is still the same. It's just now I look to here. I'm looking for a group of 4. So I want to know how many times or how many groups of 4 do I have in the number 27. Well, 4 goes into 27 6 complete times. 6 and 4 is 24. And now I have a remainder of 3. So that means I can take 6 complete m's out. And then the fourth root from here. But I have 3 m's left over from the remainder. If you want to write it like that, then fine. No, 20. Okay, so we have the square root of 24 m to the 5th. Let's split this up. We'll take the square root of 24 and then the square root of our variable. So in 24, we'll take the prime factorization. We've done this multiple times. 2 goes in 12, 2 goes in 6, 2 goes in 3. So here, because I'm in the square root, there's a group of 2's that can come out. And then everything that doesn't have a pair gets multiplied back together. So this 2 times 3 and gets put back under the radical. Here, our root is 2. So we'll ask how many times does 2 go into 5? And 2 goes into 5 2 times with a remainder of 1. So this will be equal to, let's put it down here, I have 2 complete m's that can come out from here, m squared, and then I have 1 m left over from the remainder. This is a little confusing. Let me put it on the next page. So the square root of 24 times the square root of m to the 5th, we saw this could be simplified as 2 square roots of 6 times from here, and this could be simplified as m squared times the square root of m. And now we can finish multiplying. Everything on the outside can be multiplied together. So 2 times m squared is 2m squared. And then everything under the radical, here the 6, and under this radical, get multiplied together. Okay, let's try our last one, 21. Here we have the 4th root of 32x to the 10th. So we can split these. So the 4th root of 32 times the 4th root of m to the 10th. Same process. We'll take the square root of 32. 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. And 2 goes into 4 2 times. Since we're in a 4th root, we're looking for a group of 4's. There's a group of 4, so that can come out. It's under the 4th root, and there's a single 2 left that stays behind. that's going to be multiplied. Now here, 4 will go into 10, 2 complete times, with a remainder of 2. So I can take out 2 complete m's times the 4th root, and from here 2 m's are left over. Now we will multiply on the outside just as we did above. Again, we'll have 2m squared times the 4th root, and then we have to take what's underneath the radicals. 2 times m squared. So in the end, our answer is 2m squared times the 4th root. If you want to put the multiplication, you can, of 2m squared.